Probability. Probability is basically an easy topic to gain marks. It is tested in paper 1 and paper 2 both. Now, to understand probability, you need to understand that probability is basically linked with events. And we can directly say that events upon total number. For suppose if we can say that we have a coin. Now coin has two sides. One is head, the other is tail. Now head has one side, tail has one side. Your total number of sides in the coin are 2. So that means there are two sides in total, but there is one head and one tail. So that means to have probability of head. Event of head, how many event of head we have? 1. Out of how many total number? 2. Similarly, probability of tail will also be 1 upon 2 because tail has only one side. Out of how many? Total number as 2. Similar way, what we can have is dice. Now, we know that dice has total of 6 sides, with each number representing one side. With each number representing one side. That means if I want, a dice is thrown and the number on the dice comes 1. So 1 has one side only out of 6. So the probability of having 1 is 1 upon 6. Similarly, probability of 2 will be 1 upon 6 as well. Probability of 3 will be 1 upon 6. Probability of 4 will be 1 upon 6. Probability of 5 will be 1 upon 6. Probability of 6 will be 1 upon 6. Because each number represents only one side. Out of how many sides? 6 sides. Now, you need to understand one thing, that your total of the probability, will always be equal to 1. Your total probability will always be equal to 1. This means that when we worked upon coin has head and coin has tail. There is no other side or there is no other event in coin. And the probability of head was 1 upon 2 and probability of tail was also 1 upon 2. So that means this is 2 upon 2, which is equal to what? 1. Similar way, when we worked upon dice, that means we worked upon probability of 1, probability of 2, probability of 3, probability of 4, we worked upon probability of 5, we worked upon probability of 6. So that means all the dice should be equal to what? 1 upon 6 plus 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 1 upon 6 is equal to 6 upon 6, which is equal to what? 1. So that means the total probability for any of the event will always be equal to 1. Okay, moving further, you need to understand that there is one thing which is called mutually exclusive events. Exclusive events, where in other words we say options in event. Options in events. In normal question, the word that is used is or. There is a choice between two events, occurrence of two events. Out of those two events, only one can happen. For suppose if I say that a dice was rolled, a dice was rolled. And there's a possibility, what is the probability of getting 1 or 5? What is the probability of getting 1 or? That means you can either get 1 or you can get 5. So probability of 1 is 1 upon 2. Probability of 5 is also, probability of 1 is 1 upon 6. Probability of 5 is also 1 upon 6. So what we're going to do is we're going to add these two up. What we'll get is 2 upon 6, which is equal to what? 1 upon 3. So that means you had choice of having two events when the dice was rolled. Out of those two events, what is the probability of having 1 or 5? So adding 1 upon 6 and 1 upon 6, we get 2 upon 6. And those 2 upon 6 means we have probability of getting 2 sides out of 6 sides is what? 1 upon 3. Similarly, there can be this thing that if we say a dice is rolled, find out the probability of getting 1 or 3 or 5. Now, out of 6 sides, we need 3 sides, which means either we can have 1 or we can have 3 or we can have 5. So probability of having 1 is 1 upon 6, probability of having 3 is 1 upon 6, probability of having 5 is also 1 upon 6. So that means the total probability is 3 upon 6, which is equal to 1 upon 2. So that means out of 6 sides, 3 sides can come and 3 sides can't come. So out of 3 sides which can come, the probability of having 3 sides is 1 upon 2, which is 50%. Which is 50%. So that means that we started off with probability, normal events upon total number. Coin is head or coin is tail. Coin has head and coin has tail, which is 1, 1. Probability of getting head is 1 upon 2. Probability of getting tail is 1 upon 2. Dice has 6 sides. Probability of getting 1 is 1 upon 6. Probability of 2 is 1 upon 6. Similarly, 3, 4, 5, 6, each number has probability of 1 because each number has that one side out of 6 numbers, right? So the total probability is always 1. Now, the most important thing that we need to understand that when total is equal to 1, so all event probability is equal to 1. Any event success is 1. Now, these are the other words, synonym words used. Any event success is 1. So that means any failure of event will be 0. Exactly not happening. So that means that will be 0. Now, for suppose if I tell you this, that we have, let's say we have 2, 3, 3, 4, 4, 4. Now, this is an example from past paper. Now, the question says that there are 6 cards. 6 cards. There are 6 cards. And the question says 2 cards are picked. 2 cards are picked. So, total number, obviously, this question is linked with without replacement. This question is linked with without replacement. What is without replacement? That means once first card is picked out of 6 cards, your second card will be picked from remaining remaining 5 cards. So that means without replacement means first event probability. When you pick something from the first event, you will keep it outside or you will keep it away. So the total number will change by 1. So what was more important here was that the question says directly find, or the question will say the number greater than 20. Now, since we know that 2 cards can be picked, and obviously it says without replacement, that means once that first card is picked, you can't pick the other card as seen. So can we say the 2 numbers which can be possible in this particular case of 2, 3, 3, 4, 4, 4, 6 cards, we can have what? We can have 2, 3 as 23. The first card can be 2, the second card can be 3. It can be 23. The first card is 2, the second card can be 3. So 23 is again. Or we can have first card as 2 and the second card as 4. So the number can be 23 or 24. Or the number can be 3 to 32. It can be 33. It can be 34. Or it can be 42. 43 or 44. That means all the numbers which we got eventually from the particular case is 23. We can't have 22 because 22 has only one card is 2, right? So if you pick 2, you can't have 2 again. So 23, or we can have 24, we can have 32, we can have 33 because there are 2 cards of 3, we can have 34, we can have 42, 43 and 44. Now what does the question say? Find out the probability, find or write down the probability of the number greater than 20. So can you see that all the numbers here are greater than 20. There can not be any single number which is less than 20. So that means the probability for this particular question will be 1. Because the total number, the entire events are there as the required question. The number greater than 20, you have 23, 24, 32, 33, 34, 42, 43, 40, 43 again. So that means 42, 43 and 44. Let's just write this as 44. So that means we have all the numbers which are greater than 20. So that means the total probability will be what? Equal to 1. If the question would have said the number greater than 20, and by chance all the number would have been less than 20, then the probability would have been 0. Because there is no number that is greater than 20. So then the probability will be 0. But if the total number, the numbers that are given will have what? Number that are less than 20, then only probability will be 0. So let's just revise what we have done up till now for the probability. That probability is all about event upon total number. Then probability is always equal to, or I would say when the probability is total success, it is equal to 1, total failure is equal to 0, which means range of probability answer, range of probability answer will be from 0 to 1. That every time when you will be finding out the probability, you will be having 0 to 1. Then we did mutually exclusive. We did mutually exclusive events. Mutually exclusive is always equal. What does it mean? That means you add up two or more events because of its occurrence. Then what we did was we did without replacement. Now, without replacement means total number will change by 1. That means it will be decreased after each event. So, if we did all this, so there's one particular thing which is tested less, but it should be there. If the question says with replacement. If the question says with replacement. So when the question says with replacement, that means total number will remain same. Total number will remain same. Events are independent. Events are independent, which means that overall the first event will have no impact on the second event. So that means the total number will change, it will remain same. It will not change. For suppose if I say that we have 3 red buttons. 3 red buttons, and we say that each time we are picking one red button. So to find out that one red button, what we're going to do is we have 3 red button out of 3. So that means each time when you pick, your total probability of having red button is 1. Because each time when you will be choosing red button, you will be choosing out of 3 and you need to pick only one. So probability of having that red button will be 1. But similarly, if we say we have 3 red buttons and 2 black buttons, and now out of these, what we know is that total buttons what are 5. Total buttons are 5. So if I say what is the probability of red button of choosing one red, I'll write it down more in more theoretical mode. Probability of choosing one red will be 3 upon 5. Probability of choosing one red will be, because for that one red, you have 3 red buttons out of total 5 buttons. If I say probability of choosing one black button, so how many black buttons do we have? 2. So probability of choosing that one black button, you will have to choose from 2, but from the total number, which is what? 5. So that means whenever you will be choosing one, you will be taking out probability. You will be looking forward to how many things are there for that particular event. For suppose you are choosing one red, but you see, okay, I need to choose one red out of those 3 reds. These are all same, but from particular how many total buttons? 5 buttons. So there will be possibility of choosing one red from 3 red buttons, but total is 5. So that will be 3 upon 5. Similarly, if I want to choose one black button, if we want to choose one black button, so we have 2 black buttons for that. So the probability of choosing that one black button, you will be doing what? 2 upon 5. So now let's work upon a question that says there are 5 black balls and 3 red balls. Two balls are taken at random. Let's say with replacement. What does with replacement mean? Total number will not change. Total number will remain same. So let's just put it this way, that the first and the second. Your first can be black and the second can also be black. There's a possibility, right? Or there is a possibility that the first can be black and the second can be red. There can be first red, second black, or first red and second red. So I think there are only 4 particular choices in this question for black and red, that either you can have first black, second black, second red, first red, second black, first red, second red, and all the events are different. That means black is different, black red is different, red black is different, and red is different. For each probability, your first black probability will have no effect on black red probability. Your black red and black probability will have no effect on red black probability. And same is the case for red. So let's just make sure that we know that first and second. Your first is black. So can we say this should be 5 upon 8? Because there are 5 black balls out of total 8 balls. 5 black and 3 reds. If I want to pick my second black, this should be also 5 upon 8, because the question says with replacement. Once I pick my first black ball, obviously I need to keep it back. Now it can be kept back in the bag. 5 black balls, 3 red balls, 2 balls are taken, let's say, out of bag. Let's just include this. So that means if I say that first black ball was taken outside the bag, before taking the second black ball, I kept the first black ball inside the bag again. With that reference, the total number will not change. The total number will remain same. So since I know that black and black effect is there, so this should be multiplied, because there is a confirmation between them that if my first is black and second is black, the probability should be 25 upon 64. Similarly, now since I said that first event, black does not have any event on the, and does not have any effect on the second event. So what are we going to do is, your first is black. So black is 5 upon 8. And your second is red. How many red do we have? We have 3. We need to pick one red, but for that one red, we have 3 red out of how many? 8. So the probability is 15 upon 64. Similarly, if I say first is red, so red will be 3 upon 8 into 5 upon 8. Because for one red, you have 3 red out of how many? 8 balls. For one black, you have 5 black balls out of how many? 8. So this should be 15 upon 64. So now moving further, for first red ball, how many red balls we have? 3. out of how many? 8. So that means we have 8. And for the second red ball, we again have 3 red balls because the question comprises of with replacement. So this would be 3 upon 8 again. So this is 9 upon 64. So these are different probability of having what? 2 balls that are taken out, because out in this particular case, there can be no other option other than black, other than black-red, other than red-black, or it can be red-red. Now, if I say that the total probability is 1, so that means all the probability for this particular event should be equal to 1. You will not be required to write down this, but this is just for the concept. That means if I add all the probabilities, if I add all the probabilities, I'm adding what? Black, red, black, and red, which is 25 upon 64, which is 15 upon 64. Then we have 15 upon 64 again. And then we have 9 upon 64. So this is all 64 upon 64, which is equal to 1. That means, okay, all the probabilities, all the event will have total probability as what? 1 in all the cases. Whenever we talk about total probability, the total probability will always be depending upon 1. Now, the same question, if I want to create a tree diagram. What is tree diagram? Tree diagram is probability through branches. So probability through branches. Now let's just work upon this. Let's say that same question, we have same question. The question is of with replacement. Same thing that we'll be writing first ball and second ball. Your tree diagram will be that the first ball is black. Your first ball is black. So that means that this first ball is what? Black. So there is a possibility that the first ball can also be red. Now you need to understand this. You need to understand that the first ball can be black or the first ball can be red. There are two branches that if it starts from black, it will go up. If it starts from red, it will go down. This is the probability that the first ball is black or the first ball is red. Now, working on that, the second ball after black can be black or the second ball after black can be red. If the first ball is black, the second ball can be black or the second ball can be red. But if the first ball is not black, then the first ball will be red. That means after red, the second ball can be black or the second ball can be red. So just repeating this thing again from the tree diagram, because as I said that it contains the branches. The first ball is black or the first ball can be red. If the first ball is black, then the second ball can be black as well. So the probability is black and black. If the first ball is black, then second ball can also be red. So this will give me black and red. If the first ball is not black, then the first ball can be red. So if first ball is red, then the second ball can be black. So this should be red and black. If the first ball is red, then the second ball can be red again. So it should be what? Red and red. So that means that from here we should be getting black and black. From here we'll be getting black and red. From here we're getting red and black, and here we'll be getting red and red. So probability of having black. How many black we have? First ball is black, 5 out of 8. How many red do we have? 3 out of 8. Since the question says with replacement, that means for the second ball, the total will not change. the total will remain same. 7, 7, 7, 7. That means the total will not change to 7. It will remain what? 8, 8, 8, and 8. So that means the probability will be, for this particular case, since first is black and you need to have second as black, the probability will again be 5 upon 8. If the first is black, the second is red, it should be 3 upon 8. If the first is red and second is black, it should be 5 upon 8 again. If the first is red and second is red, it should be 3 upon 8. That means the probability for any event is unchanged. So since now I need to have black and black, the probability for this should be 5 upon 8 multiplied by 5 upon 8, which is equal to what? 25 upon 64. If I need probability of black and red, I will be doing 5 upon 8 and then 3 upon 8, which is what? 15 upon 64. Similarly, red and black, this should be 3 upon 8 into what? 5 upon 8. This is again 15 upon 64. Then 3 upon 8 into 3 upon 8. This is what? 9 upon 64. That means your tree diagram comprises of the same probability quotient. Now, the same quotient which was done deliberately in the theoretical manner has been changed to what? Tree diagram. The total probability will again be equal to 1. Okay, moving further. Now let's say that we have 5 black balls and 3 red balls. But the question is of without replacement. Just writing it down. 5 black balls and 3 red balls. The question is very clear. 2 balls are taken at random from bag without replacement. Now, the same question, but now it says number 1 without replacement, and obviously 2 balls are taken, same numbers, 5 black and 3 red. The balls are going to be same as well, black and I'll say the first ball, first and second. So the first can be black, the second can be black. First can be black, the second can be red. First can be red, the second can be black. And it can be red and red. Overall, it's the same question that we did earlier. It was just the difference between that this was with and this is without. So, probability of having first and second. So, if I say that the first ball is black, how many black balls do we have? We have 5 black balls. Out of how many? 8. Multiply by, because there is a confirmation. Now, when I pick my second ball as black, I know the first black ball has been kept outside the bag. So that means total number has been changed by 1. That means we had 5 black balls, now we will be left with 4. We had 8 in total number, now we'll be left with 7. So that means if I pick the second black ball, how many black balls I'm left with? 4 out of 7. So this should be 20 upon 56. Similarly, if the first one is black, this should be 5 upon 8. If the second is red, red has not been chosen up till now. So there are 3. But since the first was black and it has been kept, the total number will change to 7. 15 upon 56. Similarly, if the first is red, 3 upon 8. But since now I'm picking up second as black, black are 5. Black are 5. Each event is independent upon 7. So this should be 15 upon 56 again. Similarly, if I want to pick red, red is 3 upon 8 into 2 upon 7. Because red has been chosen from first, it has been kept outside. This should be 6 upon 56. If we look into the same method, the total probability of black and black plus black and red plus red and black plus red and red will be all equal to 1. Now, same question, if I want to draw my tree diagram, we will be writing down as tree diagram probability through branches, right? Tree diagram represents probability through branches. Same question as it was there, but the question is now without replacement. So first and second. So if we want to choose the first, so first is black or the first can be red. If the first is black, the second can be black or the second can be red. From red, your second can be black or second can be red. So that means the probability, since the question is without replacement now. The question is without replacement now. The first is 5 upon 8 as black. And the first will be red as 3 upon 8. Either the first is black, the total number will be 8, or the first is red, the total number will remain 8. But if the second is black, there should be 4 upon 7. And if second is red, it should be 3 upon 7 because red is not out yet. But if there is another branch, the first is red, the second will be black, which is 5 upon 7 because the black is not out yet. But with red, it should be 2 upon 7. So if I need to find out the probability, there should be black and red from here, red and black, and red and red. The probability will be 5 upon 8 into 4 upon 7, which is 20 upon 56. This would be 5 upon 8 multiplied by 3 upon 7. This should be 15 upon 56. This is equal to. Similarly, this is 3 upon 8 into 5 upon 7. This is again 15 upon 56. This is 3 upon 8 into 2 upon 7. This is 6 upon 56. So the tree diagram is represented through branches, and this is just the same question, but obviously represented in the tree diagram. Now, the question can be very different. The question such that the tree diagram is there, just linking these question to this part. The questions, as I said, that the questions can be linked to these tree diagrams, or the normal question can be write down probability of same color balls. Now, since the question says that there are two balls to be taken out of the bag at random, right? And the question asks that write down the probability of same color balls. Now that means that if the question is without replacement or with replacement, that really does not concern. But what the statement requires is that you'll be finding down the probability of black, two balls of same color, or because it can be red, as well. So probability of black and black was 5 upon 8 into 4 upon 7 plus red and red will be 3 upon 8 into 2 upon 7. So these two probabilities will be added. This is 20 upon 56. This should be 6 upon 56, which is 26 upon 56. You can always simplify this. Now, again, write down probability of different color balls. Now, what does different color balls mean? Different color balls means that it can be, first ball can be black, then the second ball should be red. If the first ball is red, then the second ball should be black. Now, obviously, there is no restriction. It's an open-ended question. That means you need to understand different color ball means if the first is black, the second has to be red. Or if obviously when the question says different color, you can always have first as red and second as black. So this should be 5 upon 8 into 3 upon 7, and obviously there are two probabilities whenever we use whenever we multiply, we always have the word that is and. So let's just write down and, we multiply, and or we plus. So we have red is what, 3 upon 8 multiplied by, there should be 5 upon 7. So the probability is 15 upon 56 plus 15 upon 56, which is 30 upon 56. So obviously you can simplify this as well. So normally the probability questions that you will have is write down the probability of the same color, black, red, write down the probability of different colors. Obviously, we will have black, red, and red, black. There are other questions as well that the question can say, write down probability of second ball as black. Now, the question here does not say anything about the first ball. The question only says about second ball as black. So there is a possibility. Now the probability can be second ball as black means we can have black and black. Or we can have red and black. We can't have red because the second ball is red. And we can't have black and red because red second will be red. So the probability that we will be needing is black and red black. So black will be 5 upon 8 into 4 upon 7 plus 3 upon 8 into 5 upon 7. So this is 20 upon 56 and this will be 15 upon 56. The probability should be 35 upon 56. Similarly, the question can be, write down probability of having at least one black. At least one black means you can have two, but one is the minimum requirement. So what we can have is black. Obviously, we can have two, but one is the requirement. Or we can have black and red, at least one is black. Or we can have, but we will not be needing red and red because it does not have. So for this, black and black probability was 20 upon 56 in the tree diagram. This was 15 upon 56 and this was 15 upon 56 as well. So this should be 30, this should be 50 upon 56. So the questions in the tree diagram or in any question can be comprised of such way designed as write down the probability of same color, different color, at least one, second ball as black, or it can also be that it can be exactly one black. So exactly one black means only one black is required. So that should be black and red or red and black only. So normally we started off with normal head and tail, then we based on coin, we worked upon mutually, we worked upon with replacement, without replacement. Now remember this, these all questions can be based upon with replacement as well. But for this particular with replacement questions, remember that the total number will not change. If for suppose if I need black and black, with replacement, if the question comprises just that without replacement thing is based upon what? With replacement. So this 4 upon 7 will be what? 5 upon 8. This 2 upon 7 will be what? 3 upon 8. But this will only happen when the question says with replacement. Okay. Now moving further, there is one other thing that is there in the syllabus, that is possibility diagram. Now, possibility diagram is made when you have lot of outcomes. For suppose the question is based on 2 dices. So that means when we need to take out some of those 2 dice, or we need to take the product of 2 dice, the possibilities will be equal to number of sides to the power how many dices we have. So that means the possibilities will be what? 36. So how do we just solve 36 possibilities? So we need to understand this thing. For this thing, we need possibility diagram to represent. For suppose the question wants sum. The question wants sum. So for this sum, we will be adding all the possible outcomes of the dices, and the possible outcomes of dices can be based upon your dice's number. For suppose in dice 1, this represents D1, and let's say this represents D2. We'll have 1, 2, 3, 4, 5, 6. We'll have 1, 2, 3, 4, 5, 6. And the question says we are adding the numbers. That means the 2 dices are thrown and the numbers on the 2 dices are added. The number on the 2 dices are added. So what we're going to do is we'll add all the numbers. So that means 1 plus 1 is 2, 3, 1 plus 3 is 4, 1 plus, we'll directly say as 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4. Similarly, 1 plus 4 is 5, 1 plus 5 is 6, 1 plus 6 is 7. This will be 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5, this would be 6, 7, 8. Moving further, 3 plus 1 will be 4, this would be 5, 6, 7, 8, 9. This should be 5, 6, 7, 8, 9, 10. This should be 6, 7, 8, 9, 10, 11. This should be 7, 8, 9, 10, 11, 12. So the 2 dice's sum will be based on this. So if you look at the total possible outcomes, 6, 6, 6, 6, 6, and 6. So the total outcome that you have is 36. So if I say I need to have what? Probability of 2 in this. Let's say if I want to have the total number was given. Now if I say probability of sum is equal to 2. So to have sum equal to 2, you see that when 2 numbers are added, you have only one sum that is equal to 2. All the numbers are greater than 2 then. So that means I can easily write down my probability as 1 out of 36. Similarly, the question can be sum greater than equal to, let's say, 10. So greater than equal to 10 means 10 is inclusive in this. So that means if 10 is inclusive, 1, 2, 3, 4, 5, 6. We have 6 numbers that are greater than equal to 10 out of how many? 36 numbers. So what we're going to do is we're going to write down 6 upon 36, which is equal to 1 upon 6. Similarly, the question can be based upon that the sum is less than 4. So that means less than 4 means 4 is not included. All the number less than 4 will be included. If it was less than equal to, then we would have taken 4 as well. But since less than 4, so we will only do 3, 3 and 2. So how many numbers do we have? 3. Out of how many numbers? 36. So this should be directly written as 3 upon 36, which is 1 upon 12. This is sum of less than 4. So these questions are normally based upon the two dices when thrown and multiple. Now, the possibility diagram cannot be based on the sum as well. It can be based upon the product. And for that product thing, what you will be doing is that you will be easily multiplying. That means this 1 will be multiplied by 1, you will get 1. 1 multiplied by 2, you will get 2. 1 multiplied by 3, you will get 3. 1 multiplied by 4, you will get 4. 1 multiplied by 5, you will get 5. 1 multiplied by 6, you will get 6. Similarly, 4 ones are you will get 4. 4 twos are you will get what? 8. So you will be multiplying those two numbers if the question says product. If the question says product. But similarly, there can be question based on the possibility diagram that. So as I said, there's other question that it can be tested in terms of probability, same as possibility diagram. Let's just take down the example from past paper question that is tested in November 2016 paper 1-2, which is question number 18. And obviously question number 17 from my book. Now, considering the fact that we know that this question has 4 cards are marked with 1, 2, 3, and 4. All cards are different numbers. One card is chosen at random. The second card is chosen at random from the remaining 3 cards. That means if one card is chosen, that means if 1 is picked, you can't pick 1 again. If 2 is picked, you can't pick 2 again. If 3 is picked, you can't pick 3 again. If 4 is picked, you can't pick 3 again. So the sum of the numbers of the 2 card is calculated. Now, if you're looking at the in the possibility diagram is given in the past paper. This represents your first card, this represents your second card. Considering the fact that if I say that first card is 1, you can't have second card as 1. So that means you will not have any possible result of this. If your first card is 1, if your first card is 2, and your second card is 1, and we need to obviously sum, so this should be 3. Similarly, if I say that first card is 3 and the second card is 1, this should be 4. This 4, 1 should be 5. Similarly, 1, 2 will be 3. Then again, if you have first card as 2, you can't have second card as 2. So that means obviously because there is no second card of 2. So you can't have that possible result. So what you're going to do is you're going to mark it just like that. 3 plus 2 will be 5 and this should be 6. 1 plus 3 is 4, then 2 plus 3 is 5. And obviously you can't have 3 and 3. Then you will have 4 and 3, that is 7. 1 plus 4 is 5, this should be 6 and this should be 7. So all the possible, the question says complete the possible outcomes, which is of 1 mark. You've already done that. What is the probability that the sum is less than 2? Can we say, is there any possible outcome of having sum less than 2? There's no possible outcome of sum having less than 2. So that means that the probability here is 0. Now, what is the probability that the sum is greater than 5? Now, what does greater than 5 means? Does it say greater than equal to? No, it says greater than 5. So that means 6, 7, and 7. We'll be taking 4 numbers out of how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 4 upon 12. So that means the probability for this will be 4 upon 12, which is what? 1 upon 3. So we're going to write it down as 1 upon 3. So such questions are tested in past papers for possibility diagram. So this was the lecture number 1 from probability. We'll be working down more in lecture number 2, but this is all about probability. Signing off, this is Sir Adeel Jatoi. Thank you.